Alright, here we go. We got this equation right here. And basically, in terms of dVA, 7x minus 21 bigger or equal to 0, right? So solve this, 21 goes to the right, so x will be bigger or equal to 3. So basically it's from 3 till plus infinite with a 3 included. So next up, either the left expression is 0 or the right expression is 0. So in this case, what should I do? Well, the left expression, I can say that I can put the x up front and some from there. On the right, I don't know if I can just pop it to the second power. We'll see about that. So x up front there to the left. My video switched anyways. So x is 0, or x minus 4 is equal to 0, and x is equal to 4 right there. So basically 4 is within the dVA, so 4 is the solution. And in the second one, you just remove a square root by popping it to second power, and after this, 21 goes to the right. So pretty much the same thing as the dVA. X will be 3, which is within the dVA. So solutions, we got 3 and 4 right here. This one is pretty easy. Now we have to understand the module of this complex Z when the Z is the same as this matrix. So essentially we just plug in the last two rows, multiply diagonally, and minus the other ones multiply diagonally. I'm gonna go over this pretty fast because I've done like exercises like this. So plug it in diagonally and stuff, and just plug everything in. I'm gonna get exactly this. 0, that, this, minus this and that and this. Okay. So first up, it's gonna be 0 plus 2 plus 2i to the second power, and remember that I to the second power is minus 1, so essentially we just flip the sign there, so it's going to be minus 2. And now after stuff after the parentheses, we're going to have 0 minus 1 minus I. And we just need to switch the sign right there, these two cancel out, so we're going to have 1 plus I. That's it. So it's 1 plus I, really easy. But you have to understand the module. So formula for the module is the first number plus the second number and all the numbers to the second power under the square root. So it's going to be 1 to the second power, which is 1, plus 1 to the second power, which is 1. So basically square root of 2, which is that. So next up, there's some geometry stuff with a circle. I'm not really into circles, so I'm just gonna skip this one. This one, also circle, I'm gonna skip this one. Whatever. This one. Also geometry, perhaps gonna be done. So I guess let's try trigonometry. There's a 90-degree triangle ABC. A has 60 degrees, B is 45 degrees. But how is that possible? Saying that the triangle ABC is... Okay, so basically cross that out. It's actually not 90-degree triangle. So there's an error there. So basically A is 60, B is 45. In total it has to be 180. So when we do 180 minus 60 minus 45, we're just gonna have what's C? 60 plus 45, that's 105. So we need 75 more to get to 80. So C is 75 degrees. But you can't really do something with 75 degrees. And the angle A is... The bisection of angle A intersects with BC and point D. Then it goes to DN, perpendicular to AB. What the oh my gosh. No, bruv. It's too complicated. I'm just gonna skip this one. Look how many Pythagorean theorems and so on. Okay, so we got a probability problem. The probability of extracting winning tickets is 0.1. Find probability that from 3 bought tickets 2 are basically winning ones. Okay, so it's small probability, straight up, I can say. So first we need to calculate the anti-probability of a ticket not being actually winner. So we need to do 1 minus 0.1, which is 0.9. And we have that, and we write down 3 circles as we bought 3 lottery tickets. So basically I did kind of a lot of this once to just go through it fast. I'm focusing on stuff like I did less, like binoms and stuff. So 3 circles. You just pop a check mark when it's winner. So 2 check marks X for first case, then X check mark, then check mark X check mark, and instead of a check mark you pop 0.9 times 0.1 times 0.9 and all that times 3 because there are 3 cases. So you're gonna see how it's linear. It's pretty easy, I think, for me. So times 3 because of 3 cases, and that's gonna be 27 divided by 1000. So pretty small chance. So don't buy lottery tickets. Now here's with some graph, which I don't really care about. This is just some derivation stuff, which is also quite shite. So this is trigonometry, which obviously is not interesting to me. And that's it. I'm gonna have to find another video pretty quick. here it is. There we go. First up we go with first exercise. So same base, you just take a look at the numbers. So 5 is smaller than 6, so just write that down. But 1 divided by 3 is base smaller than 1, so it's flipped, so it's going to be actually bigger like that. So now for calculate the value of this expression. So 3 up front right there. We just work with what's within the square root for now. So essentially 32 at the power of minus 0.6. Well, that's just 32 you can write down as 2 to the power of 5. So it's going to be the powers, we're going to multiply 5 and minus 0.6. So we're going to have 5 at the power of minus 3, which is essentially 1 divided by 125, stuff like that. So actually it's not 5 at the power, it's 2 at the power, so it's 1 divided by 2 to the power of 3, so it's 1 divided by 8. Now we got the 4 and minus 5 right there, so 5 times 1 divided by 8, that's just 5 divided by 8. So now we just have to do within the square root 4 minus 5 divided by 8. So we just get the common denominator 8. So we're just going to have 8 times 4, which is 32 minus 5. So that's 27 divided by 8, right? And after you got that, you just have to understand for each term which number at the power of 3 gives you that term, because we got square root of order 3, so 27 3 of power 3, that's 27, and 8 is 2 power 3, so when we remove a square root, it's going to be just 3 divided by 2. That's the response. So now we're over to the next exercise. So we have this exercise 5, matrix X. So you get this matrix, and you gotta understand if the matrix is inversible. When it's not inversible, it's equal to 0, but here is inversible, so it's not equal to 0. So this matrix X doesn't need to be equal to 0. So just crisscross multiplication and so on. You just have to know this condition. So write it down. So 4x is gonna be essentially that minus this, right? You just keep the x terms to the left. Now right there you're gonna have 1 minus 0, so that's just 1, and on to the next matrix is gonna be a bit harder. Or bruv, I think we don't need to work with such, like, this is 2019 test. Right now we just don't have such matrix operations, but this condition basically inversible can be there. Anyways, we don't have such operations, so I'm not interested in seeing how this works. I'm just gonna move on to the next one. Here we have some imaginary numbers, exercise typical. So find values, real values of P and Q, knowing that for which 2 plus I is a solution to this equation. So obviously I to the second power is minus 1. So instead of x, you just plug in 2 plus I and work from here. Use the general formula right there, 2 plus I to the second power, general formula, and so on. So you're gonna have this, I mean, that's the long form, and now it's gonna be 4 plus 2i, then again plus 2i, so basically plus 4i, and plus I to the second power, which is minus 1. and then rest of stuff plus pi plus q. Now right there we have plus 4i like I said, and minus 1, and the rest of the stuff. So we are right here, and what we can do now, 4 minus 1, basically we got 3. So right now I think we are gonna work with basically the terms that are imaginary and non-imaginary. We're gonna split it like that, so they're underlined appropriately. So we're gonna work with them. 4 plus p is 0 right there, but why just p? 4 plus p is 0. Where did the minus 1 go? Where did 2p go? Hold up. 4? Oh, so that's the imaginary part. Okay, so the non-imaginary part is this. P is minus 4. We plug in the p. You can write down like this, or with system, whatever. Plug in the p right there. We're gonna have 3 minus 8 plus q equal 0. So basically minus 5 plus q equals 0, so q is 5. So p is minus 4, q is 5. Next exercise. Some circle here, I'm not interested in that, as you know. So I'm gonna skip this one really quick. Alright, next up, some pyramid. Yeah, I guess it's pretty fucked up, so skip this one too. Come on, load. Yeah, here's with notations and stuff, it's pretty hard. Fuck this exercise. Okay, very good probability, that's what I'm talking about. You have all the numbers, and a code of 10 numbers is being formed, and they must not repeat. Find probability that the code formed randomly contains 1, 2, 3, basically like this. So here obviously it's not with anti-probability. We pop 10 circles as we have a code of 10 digits formed. And here's like the formula: favorable cases divided by all cases. All cases, what's that? I think it's just 10 exclamation mark, because right, they just have to not repeat, so we got the 10 exclamation mark. It can start with 0, right, as far as I know. So now what? Basically then, now we need to calculate the favorable cases, and here you have to think about combinations and arrangements, if we need them, which one we need. So essentially you can write down 1, 2, 3. It can either be the first 3, or starting from the second and starting from the third. So just write down all the cases. So 3, 2, 1. Why 3, 2, 1? Okay, so basically this is 10 exclamation mark, like I said. So M is like, bruv, can either be here. So 8's right there, so pretty much 8 cases. So 1, 2, 3, 4, 5, 6, 7, 8. 8 cases of it being switched around, as we need to have a sequence 1, 2, 3. So basically 8 cases, and the rest of them is like 7 exclamation mark. Early note here is done without with C and A combinations and stuff. It's not used here. 7, 8. So 8 exclamation mark, huh? Because that is switched around and stuff, I guess. 8 exclamation mark. That's it. Well, yeah, that's that. You just take it at the end and pop it like this. It's kind of an approach. So whatever, 8 like that. So we have 9, 10 right there. So it's 1 divided by 90. Sounds like not that clear, but whatever. Next up, what do we have? This graph sequence, trigonometry, and yeah, like that's it. That's we have the equation right there. What else do we have? This sounds pretty hard, so fuck it. So find something else, and yeah. note another video. Here we go. So work with stuff in the square root, boom, that's it. It's pretty much similar to the ones that I did not so long ago. So 81, that's 9 power of 2, so that's 0.5, so that's 3 power of 2 times 1, so basically it's gonna be 1, 3, so 3, right? So that's 3. Now in terms of log, right there, 2 base, and then the number itself is 1 divided by 32. You can write down as 2 to the power of minus 5, so it's just going to be minus 5, so 3 plus 5, 8. So what number of power of 3 is 8? 2, so that's it, the result is 2. So you can see the flash process right here. I mean, it's straightforward. Okay, now next up we got this an equation right here. So if it's a fraction like that, what we need to do basically is divided by x plus 1, right? So we need to pop that number bigger than 0. Actually fucking not equal to 0. Okay, I forgot. So x is not equal to minus 1. That's dv right there. So now we move our 3 to the left, so it's going to be minus 3 and equal to 0. Now we just, the 3 part we multiply with x plus 1 and work from there. Yeah, so let's go. X is 0. X is 0. So just plug in like x is 0. Y, I don't know. I guess I could try to understand the logic, but whatever. So we're just gonna have this, so we're gonna have this, 3 minus 3, which is 0. I mean, perhaps you just proved that that's 0. And we can move that to the right also, and we can crisscross multiply, right? And we're gonna have this, and we're gonna have this, and so we're gonna have this. So that's minus 4x equal to 0, and 4x is equal to 0, so x is 0. So that's a method right there. Another method is to just multiply by x plus 1 like I've shown before. I mean, I said before, I didn't actually show, it's being shown right now. And so we're gonna have minus 4x on top, x plus 1 below, work with what's on top for some reason, and x to 0. Now minus 1 right there, value, 0 value, and I think right here we have to work with basically plus or minus if it's negative or positive. So we take a number, so for example on the right of 0 we have 1, we plug it in, so we're just gonna have 3 minus 1, which is 2, and below we're gonna have 1 plus 1, which is 2, so 1 minus 3, so it's gonna be negative, so negative, positive, negative, that's how it goes. The interval, so basically we need negative values, so we're gonna take the values from minus infinite to minus 1, and then from 0 inclusive to plus infinite. So exactly what I just said is being shown here. So next exercise now. Point grading system is being shown right now. Okay, now we have this imaginary number exercise, whatever. Pretty quick, you know how it is. No time to waste here. You just plug 2 more rows below, do multiplication and so on to have a d value. We're gonna have 4 plus minus 1 plus 0. Now minus, and if other time thing diagonally multiplied, 0 plus 2 plus 2. So there we have 3 minus 2 and minus 2, so minus 4, so minus 1. So this d is minus 1, we plug it in. So we're gonna have z plus 1 in power 2's right there, plus 1 equal to 0. Here, I think we can just move 1 to the right and pop everything to square root, so we can just remove a power of 2. I mean, there are multiple methods. We can just use a formula to understand what is z plus 1 all to the second power, and so on. So now we have this. I mean, he chose this method to just multiply term by term, and perhaps you're gonna get some quadratic. So z right here, then we have another z, so 2z essentially, and 1 to the second power, which is just 1. So the plus 1, and now we have z at the second power plus 2z plus 1 equal to 0. I mean plus 2. And now we just solve quadratic, so we're gonna have 4 minus 4 times 2. And that's 4 minus 8 minus 4. And we just extract the square root from that. Minus 4 is essentially 4 times I to the second power, so square root of that is going to be 2i, right? So now we solve z1 minus 2 minus 2i, and below we're going to have 2, and now everything like this, divide it, minus 1 minus I right there, and for the second one is just minus 1 plus I. So these are our responses. Z1 is this, and we just don't even need to write Z1 is this and Z2 is that, just like so, mate. Okay, so now up to the next one. Now, what exercise now? Some circle exercise right now. I'm just gonna skip this one. Alrighty. Volume exercise. So 12, 12, 12. I think this one's a bit hard, so I'm just gonna skip this one. So now we should have a probability, right? Great. We have negative probability and normal probability. And we have two events. One person is being employed and at least one from the 2 persons is employed. So just pop 2 circles. First check mark if it's employed, X if it's not employed. So in the first case, it can either be check mark X or X check mark. So just plug in values. check mark is 3 divided by 4, x is 1 divided by 4, do times, and then times 2 that. In the second case, it's the same stuff, but also there's a case where they're both there are two check marks, essentially, because it can be such a case, favorable case, where they're both employed. So this guy chosen the method with plus minus. I mean, it's the same, just different interpretation. So that's how it is. That's that. So that's the second case for the B. And that's that. And that's this. And so we have this. So 6 plus 9, that is 15. And divided by 16, that's probability quite high. And for that is another method right there. Now we have some sign stuff, so we obviously gonna have to skip this one. And what else is here? That's it, right? Gonna have to find another video. So it's a bit hard with fucking an equation and stuff, so another one. found this one. Essentially 10 white balls and 6 yellow balls. 5 balls are taken, and we need to find probability that at least 3 balls are yellow from 5 taken. So that's the formula right there. M divided by n, obviously, and for the total number of cases, as I usually do, first I calculate the total number of cases. So what I need to do is this: total number of cases. We have in total 16 balls and 5 are being extracted, so C, 16 below and 5 on top. That's what it is. So we can solve that. 16 and 16 minus 5 below, that's 11 exclamation mark and 5 exclamation mark added to that. So right there we have on top 12 times 13 times 14 times 15 times 16, and below we have 2 times 3 times 4 times 5, and we can just simplify 3 right there, 3 with a 3, 4, 4, 2 right there, and we will have 1 below, and on top we're gonna have quite a big number, 4,368. That's the end. Now we just write down 5 circles representing the 5 balls we're taking, right? And like I said, favorable cases should be at least 3 yellow balls are taken out of a 6 that are available. So it can either be, we just have to write down every case. So it can either be 3 yellow balls in first one, or 4 yellow balls, or 5 yellow balls taken, and we have to indicate all the places in which there might be. So that's that. Right here, it's not necessary to say, like, in the first row you see 3 yellow balls and 2 white balls. It's not necessary to switch them around for some reason, like the 2 white balls up front and then the 3 yellow balls taken last. Doesn't matter here for some reason. And so we just for the first row multiply accordingly with a C, because our order doesn't matter. So C, you take essentially out of a 6 yellow balls 3, so pop that, and then times the white balls out of C out of 10, you take 2, and the same stuff plus with other stuff, and you plug it into the general formula, and that's it. Times that, now plus C64 times C10(1), which is just 10 according to formula, and then C65, I think that's just what, 5 or 6. So this and 3 again, there right there, 8 right like that, and this, and now that's 10, bruv, okay, and that's 6, 16, boom, but that's times. So 6 times 5 times 4, 3 times 2. So you just do the appropriate simplifications right there, 2 right there. Right there, 5 times 6 divided by 2. Times 10 plus 6 right there. Amazing. Now simplify 6 with 3 and 2 with 4. And there 2 with 10 and 2 with 6. So what we have now is 20 times 45 plus 15 times 10 plus 6, so 20 times 45, how much is that? That just 900, and plus 150 plus 6, so it is just 1056. So plug that in. It's gonna be 1056 divided by 4368, when we can simplify that by 2 at least. I don't really know, maybe we can simplify something higher. With 16 we can, fucking Jesus Christ. So 16, so that's gonna be 666. Okay, not 666, so it's gonna be 16 by 273, and by 3 again. Okay, so 22 divided by what? By by 9. Bro, didn't show till the end. Whatever, you get a point. So now let me see, did I watch this or no? Obviously I'll remember if I watch this. So I mean, it's pretty much like similar, maybe not that similar. Let's see. So we have 3 black balls, and not known how many white balls, and 26 are taken. And find probability that, I mean, probability of what? I need to listen what probability this is. Hold up. fucking bitch. What else can I say? It's not taking 27 fucking balls. It's 2 balls. That's a B point right there. So basically, we have to understand how many white balls are there if the probability of taking black balls is 1 divided by 7 when we take 2. Okay, so I mean I ain't done like a lot of these types of problems where you already have the probability number and you have to understand like x value. Yeah, but I think we don't have often like this types of problems, so what I'm gonna say is fuck this problem, I don't need it. I'm gonna find something else. What is up, you black dudes watching me? Found this Super G video. X minus 2 bigger than 0 in DVA. Why? Because under the square root has to be bigger or equal to 0, but it's not equal to 0. We remove that because it's a fraction, so it's under, so it's bad. So x is bigger than 2. Easy as day. From 2 till plus infinity it goes. Now, DVA we have it. Now what we do? Well, like you know, there are multiple methods. First you remove a fucking inequality sign, so you put the equal sign. Move a 1 to the left. Make it a -1 or try something else. So basically that's what's done. This has been moved to the left, and now we can just, I don't know, multiply everything to the second power, or just multiply 1 with x minus 2 square root. So let's see what will be done here. X is 6. Well, how is that done? Well, I mean, I understand that x is 6, but what, that easy? I mean, if you plug in the 6, it's gonna be -2, 4 right there, square root of that, 2 divided by 2, 1 minus 1, 0, right? But like, so x is 6, so that's like an arithmetic crisscross and so on. Okay, so now on the DVA thing, we got a 6, and that is bigger than 2, so it works. So solution is 6, bruv. But here, I think we don't need just the solution, we need the interval, like from which it's positive or equal to 1. So we need to find plus minus stuff. So essentially, let's take a value. So for example 3, and plug it in. Or what better value can I take? Well, from 6 to the right, I can take 11, and 11 minus 2 square root of that, that's 3, so 2 divided by 3 minus 1, that is negative, so negative plus it goes, so right, between 2 and 6 is plus, and after that is negative, right? So it goes like this, up, down. So we need positive values, so the interval is going to be from 2 till 6, and with a 6 it's going to be with that other type of parenthesis. So that's it, mate. Let's just work it out. I guess another method is shown, or what, when we do what? When we plug in like the x minus 2 right there, so x minus 2, bro, get out. Now this, like, bro, you know what it is, multiply minus the other diagonal multiplied. So here we have a formula, z at the second power minus all that to the second power. So I mean the 3 minus I to all to the second power. I to the second power is -1. So plus 3 right there. Bruv. You're gonna note it with t. Like, come on. I guess this is a matter right here. other methods that can be used. I guess we could have moved the 4 to the right and pop everything to the second power. Anyway, essentially here we have t up front, right? Or no, t not up front. T is gonna be 4. T of the second power is gonna be plus minus 2, right? Because power of 2, 4, right? So z minus 3i is equal with 2, and z minus 3i is equal with minus 2. But 2 cases, hold up.